Hi, welcome to Easy Physics. In today's video, we'll be going over some practice problems related to kinematics, and we'll be doing a total of 10 problems. And the goal of this video is to give you guys more exposure to various difficulty of problems and different phrase problems, so you know how to approach them. And yeah, it should be good practice. So let's take a look at this first question. It says the velocity versus time graph for the motion of a car on a straight track is shown in a diagram. The thick line represents the velocity. Assume that the car starts at the origin x equals 0. And the first question asked, at what time is the car the greatest distance from the origin? So the greatest distance from the origin is just the distance from the starting point, since it starts at x equals 0. And that's basically just asking about the greatest displacement. So we have to find the time at which the displacement is the greatest. So if I illustrate this question, let's say this is our starting point, x equals 0, and we have a positive velocity going from t equals 0 to t equals 5, so that would be in this direction, and let's say so t equals 5 is here. However, from t equals 5 to t equals 10, our velocity is negative. That means it's going to switch its direction and start traveling the other way. And as it is traveling the other way, as it is traveling this way, it's decreasing the distance from the starting point, because getting closer and closer to x equals 0. So this means that our displacement is decreasing after 5 seconds. So this essentially means that our displacement will be greatest at t equals 5. And if we just look at it from a graph's perspective, we can just use the area under the curve. From t equals 0 to t equals 5, we have a positive area on the curve. And then from t equals 5 to t equals 10, we have a negative area. So the displacement would be the difference between the two areas, since one is positive, one is negative. And if you have to subtract from the original area from t equals 0 to t equals 5, that'll create a lower value of displacement in comparison to just having the positive area from t equals 0 to t equals 5. So if we just need the positive area, that'll be the greatest displacement, and that is from t equals 0 to t equals 5. So the greatest distance from the origin is at t equals 5. So that's answer choice B. So now let's look at the second part. It says, what is the average speed of the car for the 10-second interval? So in order to do this question, we have to refer back to the equation for average speed. So speed A average is just equal to the distance, the total distance over time. So if you recall, distance is a scalar value, so there's no direction involved. So despite the area here being negative, this would be a negative displacement. But for distance, there's no direction. So the total distance can be represented by adding the area under the curve from t equals 0 to t equals 5, and the area from t equals 5 to t equals 10. Adding both these areas will give us the distance. So we can do this by breaking it into a rectangle and a triangle here. So this rectangle is just equal to 3 times 8, which is 24. This sector is equal to 24. And this triangle is equal to 2 times 8 divided by 2, which is equal to 8. This small triangle here is equal to 1 times 4 divided by 2, which is just 2. And then this rectangle here is just equal to 4 times 4, which is 16. So our distance is equal to 24 plus 8 plus 2 plus 16. And this equals 50 meters. So now we can plug in our value. So our distance is 50 and our time is 10 seconds. So 50 divided by 10. This equals 5 meters per second. So our answer to the second part is D, 5 meters per second. So now let's move on to question 2. Question 2 says, consider the motion of an object given by the position versus time graph shown. For what times is the speed of the object the greatest? Okay, so from a position versus time graph, we can find the speed by comparing the slopes at various times. So one way we can do it is just to draw a tangent line, which is representing a slope at a certain time. So if we look at the answer choices, choice A says at all times from t equals 0 to t equals 2. So that would be this slope right here. And at this point here, we have a horizontal slope. We have a horizontal line. So that indicates that the velocity is 0 or not, or the speed is 0. And from t equals 3 seconds, which is right here, we have the slope going along this sector from t equals 2 to 4. So we have a slope like this, about something like this. And at t equals 4 seconds, which is right here, the slope along this line is about here, something like this. And then at choice D at 8.5 seconds, we have it right here. The slope is something along this line here. So yeah, and notice how it says speed, so we won't be considering whether the velocity is negative or positive. We'll simply just be looking at the magnitude, and whichever slope is has a greater curve towards the vertical, that's going to be the greater speed, because the slope is just equal to just change in y over change in x. So if your change in y is greater than your change in x, or not, or if your change in y is over change in x ratio is greater, you're gonna have more of a vertical slope, closer to a vertical slope. And the most vertical slope here is this slope right here, which is at t equals 4 seconds. So choice C is the right answer. So now let's do question number 3. Okay, this question says, a ball is launched off a 40-meter cliff with an initial velocity of 20 meters per second at a 36-degree angle from the horizontal. What is the time the ball takes to hit the ground, and how far from the cliff base does the ball travel? So if I was just to illustrate this, we would have a ball and it's on a cliff, and it's a 40-meter high cliff, 40 meters, and the ball is just launched off, and we're finding the time it takes to hit the ground. So we can use a displacement equation. So the displacement is going to be negative 40. So delta y equals negative 40 meters. And if we just write the delta y equation, delta y equals vi y times time plus 1/2 a t squared. And keep in mind, we're using the y components because you're using the y components to find when it hits the ground. Because when it hits the ground, the vertical displacement will be negative 40. So that's why we use the y components, because we know the values. And then so our VIY, that will just be equal to 20 sine 36. And if you just plug this into a calculator, 20 sine 36 should just be equal to 11.76, equals 11.76. And our acceleration is just equal to g, which is equal to negative 9.8 meters per second, because that's the gravitational acceleration in the y direction under free fall. So now we have our value, so now we can plug in. So negative 40 equals 11.76 t plus 1/2 negative 9.8 t squared, and this just simplifies to negative 40 equals 11.76 t minus 4.9 t squared. So now what we have here is a quadratic. So if I was to bring this negative 40 to the right side, we would have our quadratic will be negative 4.9 t squared plus 11.76t plus 40 equals 0. And you can solve this by hand if you want, but just for sake of time, I'm gonna use a calculator. So negative 4.9 t squared plus 11.76 t and then plus 40. If you're gonna get two values. One is 0 and one is 2.367. But if our object is traveling free fall, it can be 0 because then if the time is 0, then it wouldn't have traveled a distance at all. It would just have stayed here, but it's traveled off a cliff. So your answer is t equals 2.367, and this is the first part. So now to solve the second part, I'm gonna clear some space quickly, and we have our time. So now to find the how far from the cliff space, that's basically just asking for us for the horizontal distance or displacement. So delta x, I'll say, is equal to vi x times time. So vix is just equal to 20 cosine 36, and this is equal to, if you use a calculator, 20 cosine 36, that should just equal 16.18. And then our time we solve for is 2.367. That's the time it takes to hit the ground. So delta x equals 16.18 times 2.367, and just plug this into a calculator and you should get a value of, let's see, 16.18 times 2.367. You should get a value of 38.3 meters. So yeah, now let's move on to the next question. Okay, this question says a plane is flying 40 meters per second northwest. The plane encounters a windy area. If the plane's distance traveled is 230 meters west in 6 seconds, what is the speed and direction of the wind? Okay, so when we go inside a windy area, our speed is going to change to adding the components of the wind speed to our original speed. So for example, if I was traveling 5 meters per second east initially in a plane, and then I encounter a windy area, and the speed of the wind is 2 meters per second east, my new speed in the windy area is going to be 7 meters per second east. So you're basically just adding the components. And using this concept, we can now approach this problem. So doing these type of problems, it can be really simple by making a coordinate plane. So if I make a coordinate plane and positive x-axis represents east, negative represents west, positive y represents north, negative y represents south, we can just make a vector. So 40 meters per second northwest will be going this direction, and let's just label 40 meters per second. And keep in mind, whenever it says northwest or southeast, northeast, something like that, it implies that the angle between the horizontal and the vector is 45 degrees. And northwest is different from north of west because whenever the phrasing is north of west, it'll specify a specific angle between the horizontal. So now, given this given this angle we have, we're gonna use the angle from the positive x-axis, because the angle from the positive x-axis, so this angle, that also gives us direction. Using the 45 degrees here, it'll just give us a positive value regardless. But the angle from the positive x-axis to this point here, that'll give us the direction as well. So it'll show the value as a negative and positive based on the direction. So the angle here from the vector from the positive x-axis to the vector is 135, and that's because this first quadrant makes a 90-degree angle. That's 90 degrees, and then the second quadrant is also 90 degrees. But if this angle is 45, then this small angle here must also be 45. So then 45 plus 90 is 135. So we have to find the vertical and horizontal components of the wind speed in order to find its final component, or its hypotenuse. So if you notice the question, it says the plane's distance traveled is 230 meters west, and it's traveling in the west direction, despite having a vertical component of velocity going in the north direction. So if it's not even traveling in the north direction, in the vertical direction, that must mean that the velocity, the net velocity, must be 0 in the vertical direction. And if the net velocity is 0 in the vertical direction, that must mean that the speed of the wind is equal to the speed of the plane in the y direction. And if it's canceling out, if this vertical components are canceling out, that must mean that they're traveling in opposite directions. So if we know that the plane is traveling north direction, so that must mean that the wind is going in the south direction. So using this information, we can now find the wind speed by first finding the plane speed. So the speed of the plane in the y direction is just 40 sine 135. So 40 sine 135 is equal to, if you plug it in, you should get 28.28, 8.28 meters per second. So now this also means that the speed of the wind in the y direction is equal to 28.28, except it's a stroke traveling in the opposite direction. So now we have our vertical component for the wind speed. Now we need to find the x component. So if we look at the question, it says it travels a net distance, x distance of 230 meters west in 6 seconds. So if we find the speed the plane must be traveling at to cover that much distance in 6 seconds, the speed equals 230 divided by 6 because of distance over time. I'll just write distance over time. I'll specify this here, and then this equals, if you plug into a calculator, you should get 38.33 about meters per second. So now the horizontal components of the plane speed and the wind speed, they must create a net value of 38.33 meters per second. Because in order for the plane to travel at this speed, the wind must be either adding or subtracting some x component velocity to the plane's x velocity. So we can just represent this as the speed, which is this value here, is simply the net result between the speed of the plane in the x direction and the speed of the wind in the x direction. And we're showing a positive symbol because we don't know if the wind speed is adding or subtracting to the plane speed yet. So if the wind speed was adding to the plane speed, they would have the same sign. The plane speed and the wind speed, they'll produce the same sign. They will either be both negative or both positive. But if they were going in opposite directions, they would have opposite signs. So one would be positive, one would be negative. So using this information, we can first find the plane speed in the x direction. So SPX is equal to 40 cosine 135. If you plug this into a calculator, you should get just negative 28.28. And also important to keep in mind that this is our speed, but because we have to find that we are including direction, since this is traveling in the west direction, we would be plugging in negative 38.33 for speed. So, and we have for in the x direction for the plane, we have negative 28.28. So now we plug this into our equation. So we have the speed equals negative 38.33, and this equals the horizontal component of the plane speed, which is negative 28.28, and then plus the horizontal component of the wind speed. So now if we just add this on to the 38.33 side, we just get the wind speed in the x direction is equal to negative 38.33 plus 28.28, and this just equals negative 10.05. So since our value is negative, also indicates that the wind speed is going in the west direction. So now we have our vertical component of the wind speed and our horizontal component. We have these two values right here. So now using these two values, we're going to find the magnitude or the hypotenuse to find the speed of the wind. So let me clear some space here. If I clear some space right here, and I'll clear all this extra work out as well. So now all we have to do is we can just set up a vector going like this. So we know that the wind speed is in the y direction is traveling in the opposite direction of the plane speed in the um, y direction because it cancels out. So we can just say negative, and then we'll draw our vectors 28.28, and going in the west direction we have 10.05. So now we just have to find this length here, and this length I'll just say is x. So x equals the square root of 28.28 squared plus 10.05 squared. I'm just showing these values as positive because when you square these values, they anyways end up positive. So if you plug this into your calculator, you should get a value of about 30.01. So x equals 30.01 meters per second. So that's our speed. And now if you want to indicate the direction of the wind, we already mentioned that it's going, the y component is going south, and the x component is going to the west. So we could just say south of west, but if you want to find a specific angle, you could do the sine inverse, cosine inverse, tan inverse, it doesn't matter. I'll just do the sine inverse, I guess. So we could just do the sine inverse. And remember, it's important to indicate the direction. So it's going down. So sine inverse would be equal to the y over the hypotenuse. So negative 28.28 over the hypotenuse of 30.01. And this equals, if you just plug into a calculator, you should get a value of about negative 70.45. So yeah, that would be our angle from the axis, and then it's also important to know that this is our angle from the horizontal here. So this is our angle from the, so if this is the, if we assume this is the wind speed vector, which is here. Our angle here is negative 70.45. And if you wanted to find it from the positive x direction, you could just add 180 and then this 70.45 here, and that would get you your angle from the positive x-axis. So yeah, let's move on to the next question now. Okay, this question says, a soccer ball is kicked at an angle of 37 degrees from the horizontal towards a goal that is 1.677 meters away. What is the height of the ball at the goal if it reaches the goal in 0.3 seconds? Okay, so for this question, we don't know our velocity. All we know that it can be represented, the x and y components can be represented based on the angle. So we know that our velocity in the x direction is just v cosine 37, assuming that v is the velocity it's launched with, and vy, our velocity in the y direction, is v sine 37. And in this question, we can't use the vertical displacement equation because we don't know where our initial velocity is. But we can solve for our initial velocity using the horizontal displacement equation first. Because we're giving our distance, we're given our horizontal distance, which is 1.677, and we're given our time it takes to reach that horizontal displacement, which is 0.3 seconds. So using that, we can solve for v. So delta x equals vx times time. This is just a standard formula. So then, and we know that our vx is v cosine 37 times 0.3, and our distance is 1.677, so we can plug these values in. So 1.677 equals v cosine 37 times 0.3. And if we solve for v, we get v equals 1.677 divided by the product of 0.3 times cosine of 37. And that gets you a velocity of 6.999. For this question, we'll just round to 7. So our velocity is 7. So now that we have our velocity, we can find its vertical component. So Vy is just equal to 7 sine 37, which is equal to, if you plug into a calculator, to 4.21. And now that we have our vertical velocity, we can find the height of the ball. We can solve for the vertical displacement of the ball. So I'm gonna clear some room here. So we can use the vertical displacement equation. So delta y equals v y t plus 1/2 at squared. And we know that our initial vertical velocity is 4.21. We know our time is 0.3. We know our acceleration is g, which is equal to negative 9.8. And yeah, we can plug these values in now. I'll just specify here that a equal to g equal to negative 9.8. So now delta y equals 4.21 times 0.3 plus 1/2 negative 9.8 times 0.3 squared. And if you plug all of this just into a calculator, you get about 0.822 meters. So delta y equals 0.822 822 meters. So that's our answer. So let's move on to the next question. Okay, this question says a ball is shot in the air from the ground at an angle of 40 degrees from the horizontal. If at time t the ball reaches a horizontal distance of 25 meters and a vertical height of 15 meters, what is the velocity the ball was shot with? Okay, so we're solving for velocity. And in this question, we have two unknowns. We don't know the time and we don't know the velocity. All we know about velocity is the angle of the horizontal and vertical components. All we know is that we can represent Vx as V cosine 40 and Vy as V sine 40. And so basically how we approach this question is that we have to create a system of two equations using the vertical displacement equation and the horizontal displacement equation. And we're going to have to substitute the values of t between those two. So I'll show you the vertical equation first. So delta y equals v, let's just say vyt, initial y velocity, plus 1/2 g t squared. I'll just say g, that's acceleration, and then delta x is just equal to vx times time. So if we just like plug in the numbers we know so far, we can get a height of 15 for delta y, so 15 equals, and for vy we get v sine 40. We get v sine 40 times time, and if we simplify 1/2 times g is just negative 9.8, so negative 9.8 times 1/2, that's just negative 4.9. We get minus 4.9 t squared. And then for the x equation, we get a horizontal distance of 25, which is delta x. So 25 equals v cosine 40 times time. So now we can we can solve for t using the x equation and substitute that value in the y equation. So we can say that, I'll write it here, t is equal to 25 divided by v cosine 40, and now we can plug this back into this equation. So 15 is equal to v sine 40 times the time, which is 25 over v cosine 40 right here, and then minus 4.9, 25 by v cosine 40 squared. So let's simplify this. So for this term here, this big term here, the v's can cancel out. And if you didn't know, sine 40 over cosine 40, that'll just equal tan 40 because the formula of tan theta is just sine theta over cosine theta, which is the same as y by x from the questions we've been doing. So this can simplify as 15 equals 25 tan 40 and minus 4.9 times 25 by v cosine 40 squared. And now we subtract 25 tan 40 to the left side, so 15 minus 25 tan 40, that'll equal negative 5.977. So negative 5.977 equals negative 4.9 times 25 over v cos 40 squared. So we divide by negative 4.9 on both sides. So we get 5.977 divided by 4.9. When the negatives just cancel out, that equals 1.21 or 1.22 if we round. 1.22 equals 25 by v cosine 40 and all of this squared. So now we can square root on both sides. Square root here, square root here. And we can further simplify this with saying 1.1 about equals 25 by v cosine 40. And if we just manipulate this, you'll get v equals 25 by 1.1 cosine 40. And if you just plug this into your calculator, you should get a value of 29.67 rounded. 67 meters per second. So yeah, that's our answer. Okay, this question says, a snail is moving along a straight line. Its initial position is x equals negative 5 meters, and it is moving away from the origin and slowing down. In this coordinate system, the signs of the initial position, initial velocity, and acceleration, respectively, are... Okay, so we have 4 choices. So the best way to approach this problem is just to illustrate it. So if we just make a plane a coordinate system, let's just say this is x equals 0. So, and this is x equals negative 5. So this is the point where the snail starts right here. And the question is saying that is moving away from the origin. So that means it has to be going to the left. It's going to the left, but it is slowing down. So if its velocity is going to the left, but slowing down, that must mean that the acceleration is going in the opposite direction. So that means acceleration must be going in this direction, the right direction. If it's slowing down, if the velocity going left is slowing down. So acceleration must be going right. Velocity is going to the left if it's going away from the origin, which is x equals 0. And the initial position, it says, is x equals negative 5. So that's just negative. So if we look at our choices, our position should be negative. All of them show negative. Our velocity, since it's going to the left, that means it's also negative. And that eliminates choices A and D. And our acceleration, it's going to the right, which means it's positive. So that leaves choice B as our right answer. Okay, this question says to compare the times it would take the balls to reach the ground. In scenario 1, we have a ball which is x meters above the ground. Scenario 2, we have a ball on an inclined plane that's going to roll down x meters. And scenario 3, we have a ball with the initial horizontal velocity of v that's also going to be falling x meters. So if we compare scenario 1 and 3, the only difference is that scenario 3 has initial horizontal velocity. However, the time it takes to reach the ground is determined by the vertical displacement and the initial vertical velocity. So the horizontal velocity has no impact on the time it'll take to reach the ground. And if we compare those two values, the displacement vertically and the velocity vertically, both of them have the same. Both of them have initial velocity of 0 in the y direction and are both traveling a vertical displacement of x meters. Therefore, t1 and 3t, they're going to have the same time to reach the ground. So t1 equals t3. So now let's compare both of these to t2, the time it will take for t2. So inclined planes, they function differently from your regular x and y axis. On an inclined plane, your x and y axis, they're rotated along the axis of the plane. So we can so on an inclined plane, the acceleration component has to be broken to its x and y components. And on an inclined plane, the x component is the component that goes along the direction of the ramp, so this direction. And the y component is the value perpendicular to the ramp, so something like that. So I'll illustrate it. So the gravitational acceleration of g is always going downwards. And if we break it into its components, I'm going to overlap on this side a little. This, and then we have this component here. This is a right angle. And if we assume this is theta, this angle is also theta. And that's just, you can just get that through geometry. You don't need to know derivation. So using this information, this component here would be g sine theta. And this component here would be g cosine theta. So the acceleration along the ramp will be determined by g sine theta. But whenever you have a component of the magnitude, so whenever you have a component, it's always going to be less than the actual hypotenuse. So g sine theta, and this also applies to cosine, but we need sine for this case. G sine theta is always going to be less than g. And g sine theta is also the acceleration along the ramp. So that means it's traveling the same distance along the ramp as scenario 1 and scenario 3, but it's traveling with less acceleration. And if it has less acceleration, it's going to take more time to reach the end here. It's going to take more time to reach this point. So just to illustrate, I can just write a2, acceleration 2 is less than acceleration 1, and the acceleration is equal, and acceleration 1 is equal to acceleration 2. So because it has less acceleration for scenario 2, it will take more time to reach the end, and therefore t2 is greater than t1 and t3. So if we just write this in a statement, we can get t2 is greater than t1 equals t3, something like this. And one other thing you should just take away from this is to know how inclined planes work. So on an inclined plane, you're gonna have your acceleration component, which is g, and you can break it into its vectors. And these vectors, one of them goes along the slope of the inclined plane, and one of them goes perpendicular to the slope. So yeah, that's just something else to know about inclined planes. Okay, this question says two automobiles are 150 kilometers apart and are traveling towards each other. One automobile is moving at 60 kilometers per hour and the other is moving at 40 kilometers per hour. In how many hours will they meet? Okay, so if I illustrate this, let's say let's just say this right here is automobile 1. So this is automobile 1, and from a distance of 150, this is automobile 2 right here, automobile 2, and the distance is 150, and one of them is traveling this way at, let's just say this one's moving at 60 kilometers, this one is moving at 40 kilometers, let's just say. And this is on 2, let's say. So the rate at which they're approaching their meeting point is 100 kilometers per hour, because one is approaching at, because after 1 hour, one is approaching to 60, is getting closer by 60, and one is going inwards by 40. If one is going in by 60 and one goes in by 40, they're getting closer together by a distance of 100 kilometers. So their rate is 100 kilometers per hour. 100 km per hour. That's the distance they close in on each other for per each hour. So that's our velocity that's happening. And at their meeting point, they're gonna travel a full 150 meters. The whole system is gonna travel a whole 150 meters. Because let's say any meeting point. Let's say from here, this goes here, and let's say from here, this goes here. Let's just assume that they're traveling the total path length of 150. This car is traveling this much distance, this car is traveling this much distance. That total equals 150. If we said that their meeting point was like here, so this car goes here, this car goes here. Again, they're traveling 150. This car's going this much, this car's going this much, and then their total is going to be 150 distance traveled. So we can take their total distance traveled, 150, and we can just find so the time. So the time is just equal to distance over speed. That's just if you manipulate your speed equals distance over time equation. So we take our total distance and we can divide it by our total speed, which is 100. And that will equal 1.5 seconds. So our answer choice is A. Okay, our last question says, a cannon launches a ball at an angle of 41 degrees from the ground. If the time taken by the ball to reach its maximum height is 5 seconds, what is the horizontal distance traveled as the ball hits the ground? Okay, so here are some of the things we can do. So we know at the maximum height that the vertical velocity, its vertical velocity at the maximum height is 0. So we can use this equation here. So VF equals VI plus AT, which is for the vertical direction, to find our initial vertical velocity. And then using trig, we can find our horizontal velocity as well. And we can also just find the distance traveled from the ground using one of the shortcuts we mentioned previously. So if we look at this equation, our final velocity is 0, and it equals our VI, which is what we're solving for, and then minus 9.8 times the time, which is 5 seconds. So if we plug this into a calculator, we simply get that 9.8 times 5 is equal to 49. So if we bring this whole term to the right, we'll get 49 equals VI, and I'll just specify Y for the Y direction. So that's our velocity in the Y direction. And if our velocity, we know that the this, like if we draw this, we know the, this angle 41, and we solve for VIY is 49. So if we want to find this hypotenuse length, we can do, or if we want to find this length here, we can just do VI by Vx, so VIY by VIX equals tan 41. This is just using trig. So this horizontal component, we want to solve for that. So VIX x would be equal to VIY by tan 41. And VIY we solved for was 49. So then 49 by tan 41. If you plug this into a calculator, we should get 56.36 for the horizontal component of velocity. So VIX equals 56.368. So now how do we go from here? So if I draw out the picture, so from here we launch it and it reaches the ground level for F, and we know here at 5 seconds it's at max height. So if you remember, one of the shortcuts I mentioned you can use is that at the max, the time it takes to reach the max height is simply half of the total travel time if it reaches the ground at the same level at as its final part of the trajectory. So it is reaching the ground again at the final part of the trajectory. So the total time taken of the whole path is 10 seconds. So our t total is just 10. So t equals 10. And then we can just use the displacement formula. So delta x equals VIX times time, which is equal to 56.368 times the time of 10. And this equals, if you plug into a calculator, or if you just, move the decimal point 1 over, you get 563.68 meters. So yeah, that is your final answer. And if you wanted to do it the long way, what you could do is after you find your initial velocity, to find the total time, instead of using the shortcut, you could use the delta y displacement formula, and delta y would be equal to 0 since it reaches the same ground level at the final part. And if you solve for your time, you would get 10, and then you could plug in 10 for the time here, and then you would get 536.68. So I'll just make a note here. Also could delta y equals 0. So then 0 equals VIYT minus or plus 1/2 GT squared. So it'll just be 49 T and then minus 4.9 T squared. If you solve for this, T would equal 10, and then delta X equals VIXT, which is equal to 56.368 times 10, and you get the same answer. So yeah, if you don't remember any of the shortcuts, you can also just do it based on pure knowledge of kinematics. But yeah, that wraps up our video for kinematic problem set. And yeah, I hope you guys learned about various problems, how you can approach them. If you have any questions, please leave them in the comment, or you can contact me directly through Gmail or my website. But yeah, thank you for watching, and I'll see you in the next video.